problem. So if you lose your password, what does Windows have to help you? The security question, that's one thing. Oh, no, they don't have a security question. No, sorry, they don't have, there's no such thing in Windows. There's something else. There's a hint. There's a hint. They have a hint. They don't have a question. That would be nice. That's like if you lose your question, you lose like your Gmail password. There'll be a question. What's your father's middle name or something? Yeah.
If you put a hint question, is that the same?
Well, I'll have to judge that offline. The hint is correct. The question's wrong. Because they don't have a second question like your mother's middle name or something. What else have they got? You can remember to make a reset disk in advance. If someone else is the administrator, they could log in and change your password for you. But that's it as far as Windows tools, as far as I know. Now, therefore, if you really get in trouble, you never use Windows tools because they're worthless. You use hacking tools. They'll blow right past it. And there's a ton of those. But I mean, this is what Windows offers you. Because, of course, Windows doesn't want to make it easy to hack into someone else's account. They want to maintain the illusion that your password will actually stop someone from getting in your machine, which is completely an illusion. If you don't lock down the BIOS, anybody can get in 5 minutes or fast or less by booting to Linux. But if you do lock down the BIOS so they can't boot from a USB or a CD, and you encrypt the whole hard drive in BitLocker, then it's really hard to get it. But if you don't do those things, the password is like the luggage lock at your suitcase that anybody can just open with a paperclip. It's a useful thing to know. Yeah.
Is AES encryption more powerful than the BitLocker?
Is what kind of encryption?
AES.
Well, I think BitLocker uses AES. AES is the algorithm used by most. It's the recommended one from the National Institute of Standards. So that's what most people are using.
Okay.
And in BitLocker, then the question is, do they implement it correctly? Because they might do something foolish, like store the key somewhere silly. And that's what the issue is. The math is beautiful, but when you actually do it, there are mistakes you can make. Good. All right. So, all right. So, what makes the guest different from a standard account?
No time limit. Isn't there no time limit?
Password, you cannot make
No, not time limit. It's the password. A guest account cannot have a password. That's the only difference. Other than that, it's just a standard account, but they can't change the password. Right. What do you get in home locations that you don't get elsewhere? Home groups, and that's it. Nothing else. All right. By Vista, this is an even more entertaining question. What's different about home groups than anything else? And the answer is nothing. There is no difference between home and work in Vista. It's one of the many half-baked things about Vista that you didn't even know why they did it until Windows 7. Like Windows 8 has got a bunch of half-baked things that will probably be extended when Windows 9 comes out. Anyway, what are the insecure, or which wireless security networks are strong enough to use these?
WPA2.
WPA2
WPA.
and WPA. WPA is fine too. All the rest of them are junk. WP and WPS both mean anybody can get in if they want to. But WPA and WPA2, if you choose a password that's not obvious, people really can't get in.
Did you have to answer both of those?
To get full credit, yes, you have to answer both of them. Yeah, they're both good enough. This is important to know, because you'll know if your company is using WPA, there's really no point pressuring them to move up WPA2. It's okay. WPA has an enterprise version, and if you've got $1 million worth of that stuff, you do not need to pay to upgrade it, really. It's good enough. If you have web, you do need to pay to upgrade it, because that's not good enough. All right, so what network locations disable network discovery?
Public and work.
Public.
Doesn't work fall into that category too?
And I think work allows you to have network discovery. But public blocks it. All right, any questions? All right, always good to answer these things. It's public that blocks it because then nobody can see your shared files to get there. With your work, you probably do want to share folders and files. That's the idea. Oh, I wanted to mention the midterm grades are up. So just click on the scores and you will see them way over on the right. I just took all the quizzes and homework up to this date and turned it into a percentage and turned that into a grade. So you got that if you care. All right. And you know, the midterm grade doesn't have any effect on your final grade. It doesn't go on your transcript. It is just to guide you so you know what's going on. If you're not doing well enough, you still have time to fix it or drop the course or something, as you may choose. And there's a lot of extra credit projects you can do if you want to make more points. All right. So let's talk about more file sharing. And file sharing is the same in all versions, except if you have Starter, you cannot create a home group. You can only join an existing home group. And if you're going to use remote desktop, the computer being controlled, acting as a server, has to have a professional version or better. So home groups we talked about before, this is intended to be on your home trusted network, and it can be used on machines with no password. which the other file sharing can't, because the home group will create a password of its own and use it just for purposes of sharing. So home groups makes it very easy to share when you're on a trusted network, share your music, share your files, share the printers, USB connected devices, and so on. But it means the machine that creates the home group must at least have home premium or better. You cannot add XP or Vista machines to home group. You got to have Windows 7 or Windows 8. Nothing else supports it. All right, and the most difficult thing is that all the locations have to be home. And if you have multiple network connections, all the network connections have to be home. If any one of the network connections thinks you are at work or in a public place, it will block home groups, because of course that's the point. If you have any connection to a public network, you presumably don't want to share your music and your printers and everything. So if you join a domain, then home groups are not entirely useless, but they change, because the problem is they're afraid you will go, if you take your machine to work and log into the corporate domain, then you take it home and join your home group, they don't really want you to collect files from work, take them home and share them with the other people at home. So your home group becomes client only. You can see things at home, but no one can see things on your machine at home. So this is a kind of weird thing to do, but it certainly is at the beginning of Microsoft addressing the enormous problem of BYOD. Everybody is bringing their own home device to work, and this is creating a lot of problems. Now you worry, what about when they go to work and do work, and then they take that thing home and leave it in the coffee house, forget it on the airplane, let their kid put BitTorrent on it and games and Trojans and everything. You've got a big problem. It was so much easier back when all machines were like this. You'd go to work and you'd use that machine, you'd go home and use some other machine. Then it's a lot more easy to believe you're controlling what's happening to your data. So this is Microsoft's attempt to limit the harm of home groups, yeah.
So is BitTorrent illegal?
BitTorrent itself is not illegal, but 99.9% of the use of it is illegal. So I installed BitTorrent using download Linux, and that's legal, but that's not what anybody's doing. Almost all the traffic, but installing BitTorrent and running it is not a crime. It is almost always, it's just like you can buy a pipe designed for marijuana, and that is not a crime. You just can't use it. So it's the same thing.
I thought it was funny how, like, if they're coming from the Bay Bridge,
yes,
they have a BitTorrent billboard as
Yeah.
you're driving in. And I thought that was the funniest thing ever.
Yeah, it's not illegal. It's just a protocol, like FTP is. Like, FTP is not illegal. It's just what you would transfer might be. And BitTorrent, it's almost, you can guarantee that everything traveling over it is in fact illegal. That's what people use it for. That's why companies always block it. And ISPs often block it, and everybody screams bloody murder. It's not a crime, why are you blocking it? You say, well, we're blocking it because, you know, it's only got a 99.9% chance of being a crime, and that's enough for us. But technically, you can use it for other purposes.
That's why it's funny, because my job is actually really big on piracy,
Yeah,
but yet they don't block YouTube. They don't block torrents.
yeah. Well, then they're fooling themselves, because that's how you do all the piracy. Anyway, but yeah, there are some people that have like political reasons, like MIT ran a Tor exit node until very recently, because they really believe in like freedom of information, but they finally, so much nasty stuff is going on Tor, they finally quit doing it. If you run a Tor exit node, you have to put up with a lot of complaints, and a lot of them are very disturbing complaints, not just copyright violation, but kiddie porn, stolen software, stolen military secrets. You have to be comfortable with all that stuff going through your network if you're going to run a Tor exit node. And almost nobody can put up with that kind of pressure. I only lasted a couple days. The DMCA takedown notices when I ran them were enough to get me to take it down. Anyway, so if you don't want to be in a home group, you can leave it. One irritating thing is you can only belong to one home group. You can't set it up at different locations. But you can leave a home group and join another. You can disable them if you don't want people using this, which is probably appropriate for work machines. Just get rid of it. It's of course a policy setting, a local policy to just turn off home groups, just like you've done in the lab. There's policy settings to turn off the control panel and many other features. That's the whole point of being on a domain. You limit what people can do to whatever fits your corporate policy. All right, so if you want to share with all other versions of Windows, then home groups are not available. So you can always do public folder sharing or any folder sharing. These are just using the same sharing features that have been in Windows since, I think, Windows NT. They just put a different GUI on front of it to make it look a little friendlier. So you're supposed to make sure all your machines are in the same work group, but that doesn't really matter anymore. Work groups are kind of just a useless appendix. You may not even know that your machine is on a work group. But if you go into computer properties, advanced system settings, and computer name, your computer has a name and it has a work group. Or unless it's on a domain, then it has a name and a domain. It's technically in a group. And back in Windows 2000 or so, you would open the machine and then you would see them sorted by work group, and it actually mattered. But it doesn't really have any effect now. As long as there's a network path from you to the other machine, you can just type, our name is C21879. So if anybody in this room wanted to access a shared folder of this, they just have to go whack whack C218-79. As long as you can reach the machine and you know its name, you could access shared folders that way. You could also see it in the network panel. There is a networks, used to be called computers near me and other things, but here's a network panel. So you see the machines in the room, see a couple of them are turned on. This is how you find them. And this process is network discovery, what's going on right now. It is checking for machines that have the firewall and location settings such that they are visible to you. And if your machine in here is set to a public network type, I will not see them. They will not appear on this list because they blocked this request. And this is going by that protocol we talked about. It is link layer topology discovery. So if you go here, there are two protocols doing this. Link layer topology discovery responder is those machines telling me where they are, and the mapper is my machine, is the protocol my machine to draw the map. So this is where most of what we're talking about today is here in Network and Sharing Center. So here you choose what type of network you've got. And this is a home network I'm on right now, so I can make a home group of this room. But I'm also connected to something called a public network, which is VirtualBox. And this is something, you know, this gets a lot of my students in the lab. If you install VMware, then VMware creates a couple new network adapters, and VirtualBox does too. And that network might be called public, because when it first appears, you just click on some box, pops up, so you want to call it public. If you call it public, you can never join a home group, because it thinks you're not at home. You're connected to some public network. So if you want to fix a thing like that, you have to run the home group troubleshooter. The home group troubleshooter is very good. It will solve all your home group problems, except if your hardware won't support it, which happens extremely often, like up in the S214 lab. Home groups just don't work up there. But the troubleshooter will fix things like setting all your network locations to home. So anyway, if you do want to configure your network for sharing, you can use these general features like change to a private network, but if you actually want to control these things in a more granular fashion, you can set up home group and sharing. You can set them up here. And let me get my, it's network discovery, should be in advanced sharing settings. So here, advanced sharing settings, there they are. Here you can do it manually, and you're doing the same thing you would have done in Windows 2000 or Windows XP. Now you can turn on network discovery or turn it off. That's new in Vista and Windows 7. But here you can turn on file and printer sharing. Now home groups are just file and printer sharing. What a home group does is it shares your files and printers, and it creates a new account on your machine with a password that it randomly creates, and you have to type that password in every home group machine. You could do that manually if you want to. That's what you used to have to do in Windows XP. You can either share with everybody, which means you give everyone full control, and then you only need to have a login to get in, or you can share with one of your accounts, and then you have to go create that account on every machine with the same password to get in. That's all home group does, is do that automatically. So if you turn on file and printer sharing here, that enables it. It opens the firewall port. It starts the service on your machine, which hands this stuff out. If you turn on sharing, so anyone with network access can read and write in the public folders, that shares them. So, all right, let's get rid of this. Escape. Go away. All right, want to make that bigger? All right. So, all right, here's the simplest case. Let everybody in the public folder. Remember, the documents container contains public documents and my documents. The point of public documents is to share with other users of this machine, but if you check that box, then all the users of any network can also get in the public folders, and that might be what you want. All right, then you can choose whether you want media streaming going on or not, and there's a couple other things here. Down here, you can choose what kind of encryption is used. The default is the stronger kind of encryption. 40 and 56-bit encryption are pathetic. They're easily cracked. They're there for backwards compatibility with really old things like DOS. You can choose whether you want password protected sharing or not. If you do want password protected sharing, then anybody connecting to your folder has to know a password which will be accepted by your machine. So they either have to type in the password every time they connect, or they have to be logged in, and they can remember that after the first time. You choose to remember that login, or you have to create an account they're logging in with the same name and password everywhere. So it's kind of a drag. That's why home groups are a lot more handy. All home groups do is turn this on and automatically create that account. And here's, you can choose to create your own home group account instead of choosing the automatically created home group account. I don't know why you do that, but you have the option. And this has been around forever. Microsoft, Windows XP had some kind of easy file and folder sharing. Every version of Windows, Microsoft decides it's too confusing for people to share folders, and they create a new way to try to make it easy. This is the latest attempt to do that. It is pretty confusing to share folders because you have to give people share permissions and NTFS permissions, and if they don't have both permissions, they can't get in. So it's very common. You right-click on a folder, you share it, and people still can't get in, and people are frustrated. All right, so here you select your sharing options, which we talked about. File and printer sharing applies to everything except media. That's media streaming. So this machine can be a server. And password protected sharing, which is pretty inconvenient unless you use home groups. So if you are using password protected sharing, then you can create an account called share with the same password on everybody, or you can just share with everybody with no password. But home groups make it a lot easier. In practice, everybody uses Dropbox. Right? This is like many other things we talked about. The Microsoft has a free solution built into Windows, and if you just go get some third-party solution, it answers your real use case much better. You get Dropbox, you can put it on your Mac, you can put it on your phone. You don't have to, it doesn't matter whether you're at home or not. Most people prefer Dropbox and Box to really solve this problem. Well, home groups are an option also. So you can share from any folder if you want to. You open a folder. Let me just create one here and let's take a look at this thing. If I get rid of all these extraneous boxes and I create a folder on my desktop, new folder, okay, to share. Okay, if I right-click, share with, I can just choose who to share with. I can share with nobody, I don't know why you'd have that, home group, or specific people. So if I do specific people, now I can choose who to share with. If I click here, I get all the accounts on this machine, other teachers and such. And then I can choose for each one of those people these permission levels: owner, read, write, and read. So that's pretty obvious what you do here. And all this is, under the hood, this is the same old sharing permissions we've always had. There's just another GUI to make it easier to share. It's another way to go. All right. That's the game there. You can go here, well, it's not there, but you can set up advanced sharing properties if you want to. Then you can control how many simultaneous users it has and what name it has in case you want its shared name as it appears to others to be different than the actual name of the folder. Those are fairly rare things. I remember back, Windows 2000 server was very annoying because the default number of shared connections was 10. And you would often share something and exceed that number. So they increased it to 20, which is a little more reasonable. Because Microsoft's recommendation is if you have more than 10 machines, you should be on a domain. But in fact, a lot of people like this lab have machines of 20 or 30 in a work group. It is a fairly common thing people do. So you can adjust share permissions. And these share permissions have been around forever. In any Windows NT. There are 3 share permissions: full control, change, and read. And you can allow or deny them. That's it. It's much simpler than NTFS permissions. And share permissions control whether you can reach that folder over the network. But even if you have a share permission, if you don't have an NTFS permission to read the files, you still can't use them. You'll see the share, it will appear in the network, but you won't be able to get in. And I think I can show you that if I just go here into my network. Computer. I saw some machines in this room on the network. These are, here's a machine in Art Extension 183. This is some other classroom. So if I double click it, we'll see what happens. Somebody left a machine on in 183, or maybe D, it might be a printer or something. Here's Science 37. Let's open that one too. There. Okay, this one's asking me for a password. That's good. That means it's got network discovery turned on so I can see it, but it isn't sharing anything with the whole world. Unless I give it a right name and password, I can't use anything on that machine. That's what you expect to see. If they had left a shared folder with share permissions turned on, but no NTFS permissions, it would show me the name of the folder, but it wouldn't let me open it. So this one might do that. Nope, this one you can't even access. Okay, it's not really there. How about this one? Okay, there's an example. This one is showing stuff. That's me. That's boring. Okay. All right. But that's what you see. All right. So that's the game there. So that's the point. Shared permissions let you access it over the network, but NTFS permissions let you do things like read, write, and execute. So you need both of them if you're going to get any good out of the folder. And that's why people get so frustrated. They try to share it and you can't get in because they don't remember you have to go through 2 steps to allow it. And all these wizards will automatically do both of those things. When you say share with this person read-write, it'll automatically open the share permissions and the NTFS permissions to let them in. All right. You can share a printer, of course. Printers are objects which lead to print drivers, which lead to physical printers, and you can give them permissions. Printers do not have the same set of permissions at all. Read, write, and execute make no sense for a printer. Printers have print, manage printers, and manage documents. This is something I saw in the cert exam, and I put on quizzes sometimes, and students always get frustrated. They give me printer permissions like full control and read and write, and there's no such thing. That's what you get. And so print is what normally everybody has. You can use the printer and you can manage your own documents. So if you print a job and you decide to change your mind, you can delete your own job. Manage printers lets you change printer properties like the size of paper, whether you use color or not. And manage documents lets you remove other people's documents from the queue. So at a company, you might take someone whose desk is near the printer and give them managed documents so they can clear out the printer queue, and so on. That's the game there. Default, everyone gets print, administrators get everything. I don't even think we have a printer in here. Let's see. Print devices and printers. And there's a printer. Neat. So starboard, oh, this thing up here is something interpreted as a printer of some sort. So if I go to the permissions, I didn't see permissions available. Let's see if anything else here has permissions. Printer properties. There we are. So here's the sharing. Sharing options. Yeah, okay, I'm not, so here's security, there we are. There's my security. Everyone has print, manage documents, special permission, creator, owner, administrators. So everyone has print, and administrators should have everything. That's the default for printers. And the only thing you have is print, manage, and manage documents. This special permissions is probably not meaningful in this case. It means more in NTFS permissions, which we're going to talk about, because NTFS permissions are actually quite complicated under the hood. Anyway, that's print server properties. You can also control what drivers are stored on the print server. If you have machines with different operating systems on the same network, which is kind of a drag, like you have XP and Windows 7, then you might have a printer connected to a Windows 7 machine with a Windows 7 driver, but it doesn't have an XP driver. Now, if the XP machine tries to print, somebody has to have the driver. You can put it on the server, or you can put it on the XP machine. Either way will work, but they're different. And so if you have a real machine that's just a print server, you'd probably put a lot of drivers on it, so it does the whole job. To make your client machines faster, you might choose other choices. But anyway, in devices and printers, you can control the properties, like what drivers are on here. You can also control spool files, which are where jobs wait while they're waiting to print, and when it's going to notify things. Print management is a general printer control panel that lets you see all the printers on your network and see how they're doing. Something you do at your place that has a lot of printers. So if you want to find shared resources, this network I pointed to, this is obviously your first stop. That's what it's there for. This used to be called My Network Places in Windows 95. It's always been here. What this actually does under the hood is terrible. This is one of Microsoft's larger failures, which they have never fixed. This thing is actually run by two services. If you look at services here, services.exe, that's what I want. Okay, here are services. Yes. Let's try Task Manager. We'll dig into services also. Here's the services. There are two services that control this network thing, and they are server here. Which I'm not seeing what. Services.msc. There we go. That's the services control panel. There's server, and there's client for Microsoft Networks. Okay. This is what I wanted to show you. The server service. Let's go up here. Okay. This supports file, print, named pipe sharing. This lets you be a server. So if you want to share your files or your folders or your printer with other machines, you turn on this service. It automatically comes on when you share something. And then it listens on ports 137, 139, 445 for incoming connections. And the result is, In MS-DOS, every single machine on a network would send a broadcast every 10 seconds telling everybody it was there. I'm station 7. I'm here. Hello, I'm station 7. I'm a printer. I'm still a printer. In case you want to print, I'm a printer. Everything would just broadcast every 10 seconds. This had the effect on small networks. It was great. You'd immediately know what was there. You go to whatever network control panel there was, it'd appear right away. On a larger network, especially corporate networks, you don't want all those stinking broadcasts. Especially 8 or 10 years ago when you had hubs instead of switches. It was really a bad idea to have every machine broadcasting all the time. So to prevent that, Microsoft created this thing called the server service and this protocol underneath it, which fills this window. And that protocol is kind of a drag. The protocol uses a browser election. This thing is filled in by a thing called the browser, and it changes one machine to be the master browser for an election, and the one machine master browser is what keeps the master list of this, sort of like a domain controller. So every machine that connects to the network, within 10 minutes, it tells the master browser that it exists. And within another 10 minutes, the other machines refresh this window. So the end result is this network thing can easily be 20 minutes out of date. So you can turn on a machine and someone's trying to see your fair file and they don't see you in this window for a long time. They can still get to your machine by clicking start / machine name or IP address. As soon as you connect, they can get there, but they won't appear in this window for up to 20 minutes, even when the thing doesn't crash. You know, that's the browser service, is the process that actually does that, the server is what shares things. Anyway, that's a useful thing to know about that browser service. You can often really connect to things. By the way, it works the other way too. If the machine is turned off and it's not available, it may linger here for up to 20 minutes. You may think it's there, and when you click on it, it's not there. So you can map a drive just to make it easier for software to use it. This is a fairly common thing you do at companies. Your local drive is C, your network drive is F or something. They tell you to store everything on F because that's going to be backed up and such. That you can take a network path, a UNC path, Microsoft calls it, it's / server / share. That's how you actually refer to a server. But you can map it to a drive like F or Z or something, and that makes it easier for software to find it. All right, so remote desktop lets you remote control a machine so you can use it. This is a licensed limited version of Citrix. Citrix is the king of this. Most companies that have servers that share out applications that use Citrix, you can get a Citrix client for your iPad to control your Windows machine and do Excel spreadsheets on it and such. And it all works very well. Microsoft bought licensed the ability to put a limited form of Citrix in Windows 2000 Server, and they called it Terminal Services. And in later versions, Windows XP and later, they put it in the professional client as well. So you can remotely control your machine, you can play videos on it, you can use any software there, you can print on it, you know, from anywhere. You can go home, your boss calls you up, says, you need you to do one more thing, you don't have to drive back to work, you can remotely connect to your work machine and get work done. But it only works if you left the machine on and if the network lets you in. You have to have a port forwarding set up on your firewall at most networks to use network address translation. So, and the traffic is encrypted. So even though you're sending traffic over the internet and it's showing your desktop and such, it is encrypted with pretty good encryption. So the terms, the machine being controlled is the remote computer, that's acting as a server. The other one is the client computer, and they have very different requirements. The remote computer must have a professional version of Windows. This thing has been around since Windows XP. But whether it's XP, Vista, or Windows 7, you must have a professional version. If you have a home version, you cannot be the remote computer for remote desktop. And all you have to have is that, and you have to have a network connection that can get there. And if you're going through network address translation and firewalls, that's not easy. And that's by design. They don't want individual people at work deciding to do this without approval from management. You have to get the management to forward the port to you. So if you're trying to just do it without permission, it won't work. That's intentional. The client computer, however, can be anything. It can be a Mac, it can be Android, it can be Windows 7, it can be Linux, it can be Windows 95, because the client computer isn't really doing much of anything. All the client computer has to do is run a remote desktop protocol client, and they're free ones you can download, which just sends the signals to control the mouse and keyboard, and then interprets the picture coming back to draw the picture. It's not really doing much. It can be anything. Of course, the RDP client that you need is included by default in Windows, and if you're using something like Linux, you have to download the program, but that's all. It's easy enough to do. In practice, very few people actually use remote desktop protocol for the purpose I just described because it is too irritating to forward the traffic to them at work, and the only thing you use it for mainly is administering servers. However, there are a bunch of other products that let you do this, like Log Me In, TeamViewer, Go to My PC, LabLink, PC Anywhere is the old one. There are many, many products to give you remote control. And all these, by the way, are a huge security risk at companies, and they tend to generally block. Just 2 weeks ago, they blocked them here. My students had homework using TeamViewer, and it no longer works on campus. They blocked it at the layer 7 firewall. And I didn't complain because I think they're right about that. It is a serious security risk. People can remote control machines, send spam from on campus and such. The right way to do it is what they switched to here. If you want to do this, you have to connect to the VPN server first and then use this remote control. That's much safer. Then only people who are authorized to use VPNs can use it. Anyway, there are many other extensions, many other products that do the same thing. So the way the Microsoft product works by default is it listens on port 3389. You can change that. And when you turn on the firewall, will automatically open that port, and then you can remote control it to anything that can get directly to your machine, which is anything on your local area network or anything on the whole internet if you have a direct network connection like dial-up. Almost nobody has a direct network connection anymore. Almost everybody's behind a router. So you won't be able to run any service that listens on a port unless you configure port forwarding on the router, something people that play games are pretty commonly used to. So that's the game. You have to use port forwarding, or you have to use Windows Gateway or something, or VPN, which gets you in. If a virtual private network, you log in there, and then you're on the local area network, and then you can go in without needing port forwarding. And that's what most companies regard as more secure, and that's what City College wants kids to do now too, which is a good idea. If you want to enable these things, remote desktop is turned off by default. You just have to go into advanced system settings and check this box. Allow remote assistance connection to this computer. That will start it listening on port 3389 and open the firewall port. If you're on a public network, it won't work because the firewall will not allow exceptions, but if you're on a private or work network, a home or work, it will let you do it. And that's fine if you can actually get to port 3389. By default, if you're in the administrators group, you can get in. If you want to let other people in, you have to approve their accounts one by one here. This is, of course, by design to limit who's doing it. And you can't have a blank password. That gets a lot of students when I do this in the lab and projects. You have to have a password on your account. That's a Microsoft security feature. Nobody should be using remote desktop to control machines with no password at all. This is something that would have done the NSA some good. The UFO hacker, McKinnon from London, hacked into the NSA because they had a machine listening with no password at all. Logged as administrator inside their network for like 2 years. Everybody was just using it. Anyway. So you can connect, you start the remote desktop client, you put in the machine's name or IP address, and then you connect. You have some equality settings, which would matter. You can, for example, choose whether you want to share the clipboard. If I copy something here, do I want to paste it on the other machine or not? You can choose whether you want sounds to come back to you, or go back whether you want printers to use your printer here or your printer there. And you can also choose how much quality you want to send. If you have a broadband connection, you can send high quality. If you're on dial-up or something, you can turn it down to where it'll only give you like low resolution, and it won't be smooth when you move things around to try to make it use up less bandwidth. And that's the Experience tab. You can control how much detail you're going to get. This is set up for low-speed broadband, 256 for 2 megs. So it doesn't bother showing you the background image and so on. Another thing that's actually kind of entertaining is it will do bitmap caching. This last option here is important in computer forensics. We play with this in the forensics class. So if you use remote desktop to control your work machine, then if you look in the cache, little pieces of your documents are there. It makes copies of images, so it doesn't have to transfer them more than once. So you can actually retrieve from a client machine some information about what they were doing that way. It's not very nice. It's like you're getting pieces of a jigsaw puzzle. But it is an interesting issue to know. Anyway, so when you're done, you can, if you try to turn off the remote machine, you will not be able to turn it off. You go to the start button, your only choices will be to lock the screen, to disconnect, which means I'm no longer remote desktop protocoling in, but it's still running, or log off, which will close off, log off. You cannot turn off the machine remotely with remote desktop. And that's the bitmap cache viewer. And this is what you see on the machine if you're using remote desktop, random little chunks of their images stored there. It's not as useful as what iPhones do. iPhones have a feature when you click from one app to the other where it shrinks down, so they keep a JPEG image of your entire iPhone screen every time you switch applications. And that stays there forever. So you do a forensic analysis of an iPhone, you find whole screen images. This isn't quite that useful. All right, you got a few eye clickers about that. Come grab one if you need one. So, a user has two machines, Windows XP Pro and Windows 7 Starter Edition, and they want to make a home group. So what do they have to do? Good, 1 minute there. Good. All right. So, the answer is E. Good, nice popular answer. They've got serious problems, right? XP and Vista cannot do home. So this is not going to do any good, and that's not going to do any good. There isn't any client for XP either. That would sure be nice, but there isn't. So the only thing you got to get to Windows 7, but you got to have something that's better than Starter. Starter can't create the home group. One of them has to be at least home premium. So none of these are good enough. All right. Now, here's stepping around forever. All right. So I got share permissions and NTFS permissions on a folder. I share, give everyone full control and administrators read. With the NTFS, I give everyone read and administrators full control. Alice is connecting over the network, and she's an administrator. So what access does she get? I've been having this slide for years and years. Ever since Windows 2000, nothing has changed on this. But you gotta know it. It's on the server cams. So I'll wait for 1 minute. Good. I'll wait for 1 minute and 10 seconds. All right. Now let me point out a few things to notice here. She is connecting over the network. Therefore, she has to have share permissions. That's the first door she has to pass through. She's in everyone and in administrators, so she's in both groups. So what control does she get? Full control, right? If you're in two groups with different permissions, you get the sum of their permissions. Okay, now she connects over the network, the NTFS permissions. She's in everyone and she's an administrator, so what does she get? Full control. Both doors are wide open. She has to pass through both doors. If either door is shut, you can't get in. So she gets full control. All right. All right, that's it for that one. Let's go to the next one. All right. Same thing, but now the permissions are different.
It looks like the same thing.
Yeah, no, look, because this is a shared. It's totally different. Totally different.
There's
Okay,
not full control in there.
Good.
I'm going to quit at 50.
It is, it has to be. It's not Steve.
All right. So she is everyone. And she first checked she's connecting over the network. If she wasn't connecting over the network, shared permissions would not matter, but she is. So they matter. She has full control, plus read, plus deny. So what does she get?
Read.
No, she gets deny. No means no. When you put a line like this here, that means you want to keep her out. So it doesn't matter if she has full control for some other reason. Deny blocks that user. And a box will pop up warning you when you set a deny permission. Are you sure deny permissions can make trouble?
But does
Because-
deny full
But it just
control
denies
mean
full
it denies
control.
every permission
Yes,
in the list?
that's exactly what it
That's what I
means.
didn't
Deny full
understand.
control means you get no access at all. Deny read would mean you still had rights. But deny full control means you have this particular user, you hate them for some reason. I want to keep that one person out of here. And this is not recommended, by the way. My Microsoft recommended procedure is if you want to keep someone out, give them no permissions. Denying them can lead to unintended consequences, especially if you deny a group. Like if you denied the administrator group, then none of them could get in no matter what you did. That would be pretty weird.
Yeah.
But,
I
so,
don't
yeah.
understand the question because I thought shared, like I
Yeah.
put it on his network, but it's still shared. You know what I mean? I
What's
guess
that?
that's how I understood it.
Well, you need to connect over a network. You have to connect to an object, and the object has an owner and it has permissions. And it has share permissions and NTFS permissions. That's how it works. So you have to have a network path, and then you have to have permission to share, or you won't even be able to open that folder. And then you have to have permission to access, you won't even see the folder. And you won't be able to open it unless you have NTFS permissions. Yeah.
That seems like when it says deny full control, that just means deny the access of full
Yeah.
control, not deny all access.
Yeah, there's a reason why, no, but it does deny all access, that's what it means. Deny full control means all permissions are denied. Just like full control means all permissions are allowed. And the reason this happens, which I might as well go into it now, since the topic has come up, is because full control is not on the disk anymore. What's actually on the disk is 14 bits. And all these things, full control, read and execute, read and write, are a combination of those 14 bits. So that's why there's that special permissions tab. So what's really going on the disk is more complicated. Full control is a shorthand, like a group for all of those 14 bits. So allow full control means they're all allowed, deny means they're all denied. That's what's really going on. And we'll get to it, I think, in a later chapter, the detailed granular NTFS permissions, which you would almost never touch, because this is complicated enough. But what's really on the disk is 14 bits of permission. Anyway, so she is denied share permission completely, and therefore it doesn't even matter what happens down here. She can't pass through the first door, and she gets no access at all. All right. Whoop. But I can go back. Ha. I can go back. There. Now I can grade it, and the right answer was A. All right, good. Okay. So let me see if I'm getting a little confused with full screen here. Good, I think that's right. Good, I haven't lost control yet. All right, so I can go down one more. All right. There. Okay, here's another one. Computer's configured like this. And it was going to use this computer as the remote machine for remote desktop. Starter edition, that IP address, that firewall. So what do we have to do that? Guess I'll quit at 1 minute. All right. So the network is fine. You have a public address. The firewall will open. The problem is you can't do it with Starter Edition. You got to have better Windows version. The remote machine has to have professional or better. You cannot be controlled by remote desktop if you're a starter or home premium, because that is not Microsoft's use case. Microsoft's use case is you're trying to control your work machine from home. They don't think you want to control your home machine from work. All right. And how about this one? This one wants to be the client machine for remote desktop sessions. It's got home premium. It's going through a router with the usual firewall. So wait until 50 seconds. All right, and this is fine, no changes needed. The client machine could be Linux, it could be a Mac, it could be Windows 95, it doesn't matter. The only thing is you would have to download a client if you use something goofy like a Mac or Windows 95, but Windows 7 includes the client. So to be the client, all you have to have is any kind of network connection that gets there, and any modern version of Windows. You can even use XP. XP has a remote desktop protocol client in it. I don't think you get quite all the features, but you can still control the machine. All right. So we ought to take a break. It's 10:12. Let's pick up at 10:25. 10 minutes to stretch your legs. Networking. All right. Command line stuff in networking mostly. All right. So, whoops, that's not it. That's it. Okay. So, this is the same in all versions. You can go to Network Configuration Center and see a little network map. And the small network map here, let me show this iFilter thing out of the way. All right, the small network map thing will just show your connection to the internet, and maybe if there's a couple things in the middle, and you can click this to try diagnosing your internet connection problems. It may show you if there's an intermediate device. There's also a full network map, which will attempt to locate all the machines you can reach and draw an accurate map. But that's there to make it easier for you to see if there's a problem, and it runs the automatic fixes. The Windows Network Diagnostics are better than they've ever been. They will try about 10 things to fix your network connection. They will try disabling and re-enabling the network adapter. They will try changing to automatic addressing with your DHCP. They will flush the DNS cache and the Netbios cache, and just try about 10 basic troubleshooting steps. But if they can't, the problem is often not in your machine. That's the scheme there. So here's the real network map. The full network map will show exactly what you've got on your network. It'll even tell where the switches are and where the hubs are. And devices that can't be located will appear down here. If you hover over a device, it'll give you its MAC address and its IP address, which is all pretty nice. It's kind of weird though, because I don't know why Microsoft thinks that end users need all this information. That is the default setting, which is something I certainly would not have done. I mean, this is, I mentioned before, this is Microsoft's imitation of Cisco Discovery Protocol. And it's strange, and if I was at a company, I would disable this stuff. Your end users don't need to know this. All your network administrators need this level of detail. Anyway, so anything that does not appear and does not support link layer topology discovery will appear down here. The device is on the network, but I can't tell where it is because it won't answer my queries. It's not putting out discovery packets. You can, by the way, install link layer topology discovery in Windows XP. There's a knowledge base optional update to do it. If you really want your XP machines to appear correctly in that map, for some reason, I can't really think of any use case why you'd need that, but you could do it if you want to. Oh, by the way, some routers have UPnP, and they can still be, they'll still provide some information through UPnP. Universal plug and play is a strange feature where devices can automatically open ports in the router to get out, which is commonly considered a security vulnerability, but it is included in most modern routers. You can turn it off in the settings in the router, but if you don't, then devices can request, please let this network travel through, and it'll let it through. Anyway, so like I said, the diagnostic framework will automatically fix a lot of problems. There's a lot of troubleshooters. My favorite is the home group troubleshooter and the Aerographics troubleshooter. Those things really work, because both home groups and Aerographics require a lot of setting adjustments, and the troubleshooter is by far the easiest way to fix them. Of course, Aerographics is gone in Windows 8. Microsoft gave up on it. It was not that big a hit anyway. That was like three-dimensional stuff. Anyway, home group issues will show you in the troubleshooting report. It'll tell you what it found. You see, it does a lot of things. It's a home group security group, home group settings. You need to have IPv6. You need to have all your networks set to type home and so on. There's a whole bunch of stuff you have to have for home groups to work. So here's some command line tools that you typically use. By far, the most important command line tools are ipconfig and ping. Those are usually what you use all the time. You do ipconfig to see what your settings are, and you use ping to see if it's working. The rest of these are used only rarely. NSLookup is useful to see if your DNS server is working, if you're going to get down on that specific problem. GetMAC is very strange just to get your MAC address. I've never used it. You just use ipconfig/all. Does the same thing. Hostname gives it the name of the current computer. That's kind of nice. although unfortunately they brought it around too late. I learned the old-fashioned way to do this long ago. If you have a command prompt, I can now do host name. You have to spell it right though. Okay, there's also echo. I think it's host name here too. Let me see. There's an environment variable. Is it host name? Might be system name. Yeah, no. I guess I thought I knew this one, but I can't remember it. System name? Yeah, I don't remember. I guess a good thing they have that command. But there's another way to get your name, and I can't remember now. You can just echo an environment variable, which has your name in it. I could find them, and I mentioned them before in case you don't remember. Here's the environment variables. If you go to Advanced System Settings, and then their environment variables are right here. Path, temp, you can zoom in a bit, temp, TMP, and so on. Looks like I can't use the mouse while zoomed in though, which is annoying. So I have to unzoom to scroll down and look for host name. Here's system variables, and it's path extension, processor, username. Oh yeah, username is the one I knew. Maybe I didn't know. It's username is how to find out who you are. That's the one I was used to, which is a different issue. And by the way, I think they might now have who I am. An old Linux command. Yeah, they now have who am I to find out who your login is. This is the one I always used to have to use, echo %username, to find out who I am. You can find out from the GUI too. If you click this, your name is right up there. That's nice. Because it is fairly common that I forget who am I. All right. Anyway, these are, so you got get Mac. Which is mighty slow, and tells you your MAC address. And then this globally unique identifier, this long horrible thing, the GUID. If you remember the first project, you had to use this to configure your, well, you didn't, you saw them go by, but you didn't have to use it. So you configure your boot menu name in a multi-boot system. This is the ultimate identifier for a lot of purposes. Every object in Microsoft has a globally unique identifier, so-called, which you can use to refer to it. But as you can see, it's not something a normal person would use. You use it inside programming and writing software. Anyway, NSLOOKUP is important though. If I ping google.com, I get an answer because my network is fine. But sometimes you won't get an answer for google.com, and yet you get an answer if you ping 8.8.8.8, which is one of Google's servers. And that's because the DNS server is down. It happens pretty often on campus. Happens a lot of places. So to test name resolution exactly, you can use NSLOOKUP. You can do NSLOOKUP of, say, yahoo.com. I don't send any packets to Yahoo. I ask my local DNS server, do you know what Yahoo's address is? And if it's working, I'll get some Yahoo addresses. If it's not working, I won't. And so this is the command you use to test for that specific problem. It is fairly common that you lose DNS service, but you're actually still connected to the internet. You can use the resources, but only if you know the numbers. Therefore, normal people can't get anything done because they don't know the numbers or anything. They just know domain names. So it's a useful thing to diagnose. That's why you have NSLOOKUP here. NetStat is quite useful if you start listening processes, like in the homework. You had to set up work 2222 listening, and so you test this for it with NetStat. NetStat -AN will show you all connections as numbers, and more will stop it from scrolling off the screen. This shows you the statistics of your network connections. Here's all the ports that are listening. So this machine is listening on 80, it's a web server. It's listening on 445, it's a file server and a bunch of other ports. And it's got an established connection to itself, and on you go. It's got TCP ports listening, it's got IPv6 connections, it's got UDP ports available, and that's what it's got. So you can see what you're doing here. So if you run a game or a remote desktop or anything that's supposedly listening and doesn't work, one of your first steps is to use NetStat to see if it's really listening. And the first thing you do in networking is ping to see if you go to connection. Next thing you might do is ipconfig. Next thing you might do for services is NetStat. And when that fails, you run Wireshark at both ends and watch what packets are leaving and what packets are actually getting sent. That's how you really get to the bottom of all network problems, is Wireshark, where you watch every packet. If you learn how to use Wireshark well, you'll be valuable to the company. Every company has one person that can really use Wireshark, and they have to resolve the tough problems. Why won't this machine log in when the others will? Why can't this one print? You know, anything over the network. Wireshark is your answer. Wireshark at both ends. What's being sent? Is it really getting there? That's really how you get to the bottom of anything. But it can take a while to hunt through those PCAPs. NetSH is an extremely powerful command. You can turn on the firewall, you can adjust settings, you can turn on IPv6, you can adjust any network thing at all with NetSH. The commands get really long, like NetSH interface, set interface, router discovery enabled. They're not much fun. They're good for scripting. Because remember, you don't need to use the GUI for anything in Windows. You do everything as command line, and NetSH is the main tool you use to make command line scripts that will totally configure complicated network settings like IPv6 tunnels and push it out in a script. Path ping is useless, like traceroute. They both do something silly. Traceroute is slightly useful. So if I ping Google, it sends some packets to Google, and Google answers them, and that's it. If I want to know the path between me and Google, I can do traceroute, Google, and this sends a bunch of packets with very low TTLs. So 3 packets go with a TTL of 1, so they will make 1 hop in the direction of Google and then die, and I'll get a reply saying I threw away the packet. Then I send out some packets with a TTL of 2 and see what is 2 hops in the direction of Google and 3 hops. So it sends out about, I think it goes 15, sends out 45 packets, 3 with TTL of 1, 3 with TTL of 2, 3 with TTL of 3, and it traces out the path between me and Google. This is slightly interesting, but for most of us, it's not really that interesting because I don't control any of those routers. Now, if you're in a huge company with like 5 locations and you have 5 internal routers, then you might want to know the 3rd router is broken instead of the 4th one. But normally, all I care about is can I get there or not. Anyway, the only thing that path ping does, which is irritating, is instead of sending 3 packets to each one, it sends some enormous amount, like 100 packets to each one. So it takes 5 minutes and gives you statistics on how many of them got lost. Again, it's very strange that you would ever need this, unless you're at a company and you own the routers and some of them are defective and you want to know which one is dropping more packets. Usually, all you really care about is yes or no, am I on the internet or not, especially for client machine. But that's path ping. Path ping will send a whole bunch of them and give you a long detail. I'll start one here and just let it go. It'll take like 5 minutes. Pathpinggoogle.com. Okay, tracing a route to a maximum of 30 hops and sending some large number of packets to each one. Okay, route is quite useful. This lets you mess with the routing table, but only if you're doing fairly advanced things, like connecting computers in complex networks. It's something you normally use only on a server or router. By the way, the Microsoft routing table is kind of entertaining to observe. If you do, let me make this bigger. There. If you use route, you see route print. I'm going to pipe it through more to make it not scroll through too fast. Okay, this is the Microsoft routing table, and if you get into IPv6 or other advanced networking, you will really get to know and love this thing. Every Microsoft interfaces all have interface numbers, which is how we refer to it in a lot of commands, and a lot of them are not real. This machine has 1 network card, number 10, the interface gigabit adapter. All the rest are fake. This is a software loopback, number 1. Here's a VirtualBox adapter, because the VirtualBox is on this machine. These are all Microsoft virtual adapters used for things like IPv6 tunnels that it creates. But 18 is the real adapter. Now I have a lot of routes. 0000000, that attaches that's a network specifier that matches every address on the IP version 4 internet. So that's the default gateway. That's the only one you really need. The rest of these all filter traffic in various ways. Most of them are really just there to tell things that are kind of obvious. What's kind of funny is the IPv6 ones. We get into this a bit in the IPv6 class. The IPv6 ones are wrong. These are FE80/64 is local on-link traffic. That's actually wrong. It should be a different slash number there. So anyway, you normally don't look at the routing table on an end device. It's a little more complicated than you'd think. But the only thing that really matters is that default gateway. All the rest of it is just automatically configured. It makes more sense if you're on an intermediate router. NBT stat shows you Netbios Statistics, which is just how you refer to local objects and printers to share them. Not really that important anymore. And I think that's it for these commands. I think I just got pictures of them. So ping just sends some packets. You can see if something is reachable or not. That's by far the most common tool. If people can't get their email, the first thing you do is do a ping to see if they can get anywhere on the internet. And then you know if the network connection is down or if it's just their browser crashed or the password's wrong for the email or something. Path ping gives you, this is what the path ping report will look like when it finishes. And it's done. Okay, there we are. It sent no computing statistics. First it does 1 hop to each one. Now it's going to calculate statistics for 250 seconds. Okay, that's coming. All right, so traceroute sends 3 packets to each one, which is a little interesting, but not really that important. Ping probably tells you what you really needed to know. By the way, an important thing to know is a lot of people don't answer pings or traceroutes anymore. If you ping, here's an entertaining exercise. Open the NSA, www.nsa.gov. Okay, there is a server there. No question about it. There's a server there handing out web pages. But if you ping it, you get nothing. Oh, it's answering now. Oh, that's because it's Akamai Edge. It's not the NSA answering, it's an Akamai copy of it. Akamai is a content distribution network that makes local copies of your page to serve remote locations. So let's try traceroute to www.nsa.gov, because the real NSA you can't get into. Byron, this is just going to go to the Akamai Edge, which is new. Anyway, I do this now and then to see what they're doing up there. It used to be fun to go to the NSA because you could see their web server on port 80, but they had like 4 hops inside the NSA and they blocked all the pings at the firewall. So you could see the web server going in here, and you do a trace route, and you see 8 hops to get there, and then all these stars. Things that don't answer will just show you stars. And a lot of things don't answer pings anymore. As you know, Windows machines don't answer pings anymore. You can configure routers not to answer pings. A lot of routers don't answer pings from the outside. So it's fairly common that things don't answer the pings even when they are there. So the utility of these tools is declining on the wild internet. It is useful on your own network, though, as long as you allow pings. So you can see your IP configuration in the GUI. You do not need to use ipconfig/all. That's an old habit we all have from years ago. You can use the graphical interface. If you go to Network and Sharing Center here, and then Adapter Settings, right-click this and go to Status. It'll tell you and in Details, you'll get the same information you would have gotten from ipconfig/all in a graphical interface. Except, I think it wasn't this class, it was another class I gave, an IP address conflict. If you have an IP address conflict in Windows 7, you get strange, inconsistent answers here, which is kind of rude. Ever since they upgraded the stack in Vista, they've created some strange bugs in their IP stack, IP protocol. Anyway, sometimes this does not agree with ipconfig/all, and that is really bad. In general, the command line tool is right when the command line tool and the GUI disagree. But it's very rude when they don't agree. And there are cases like that in Windows 7. Anyway, so here's important IP addresses you should know. 169.254. This is a special address reserved for the purpose of numbering something if it tried to get an automatic address with DHCP from the server and failed. But it makes up this address. This is intentional, so that if you don't have any server at all, and you connect 4 machines and a printer, they will make up this address and they'll be able to talk to each other even if you have no idea what IP is. This was a big issue at the beginning of the internet. In the 80s, there were a bunch of protocols that were very easy to use, like AppleTalk and Netbios. And you just put an alphabetic name on your device. Printer 1, PC 1, PC 2, PC 3, and they could all network. There were no numerical addresses at all. And then came the internet and TCP/IP, which was considered baffling and complex, and nobody wanted it. So this was designed so you could just plug together your machines with NetBIOS names, and it would automatically make up addresses and automatically network without you having to do anything about it. In the modern world, the point of this is if you see that number, this person can't get on the internet because they tried to get an address from DHCP and it failed, so the answer is reboot your machine. This is a very common problem. Your machine tried to get an automatic address from the router and it failed for some reason, like the network was too busy at that time. You can do it with ipconfig/renew with a command prompt, or you can just restart the machine, or you can just disable and re-enable the NIC, or you can run that diagnose, which will do this automatically. Any of those will do. And this is why, you know, if you run any kind of help disk, usually the first thing is did you restart the machine, because that'll fix a lot of problems. It needs to be private addresses. Anything that starts with 10 or 192.168 or 172.16 through 172.31, those are reserved for private networks only. Almost everybody's using these because they're almost all going through network address translation, but you can't get directly on the internet with these packets. Nobody can, if you send any packets to the internet addressed to these addresses, it will just be thrown away because they don't tell you where the machine is. Every machine in America is 192.168.1.101. So that doesn't tell me anything. You've got to give me a real public address. And so these have to be translated to a public address by your network address translation gateway, which is typically a router. And so that's the thing to know about that. People try to connect directly to the internet with these addresses. They're not getting there. 0, 0, 0, 0 is what you will see if the cable's disconnected or if there's an IP address conflict that was correctly resolved by Windows, which was always the case in Windows XP and not that much the case in Windows 7. Or if for some other reason the networking cannot happen, it will set itself to 0, 0, 0, 0. You can't send or receive any packets with an address like that. So after the IP address comes the subnet mask. The only subnet mask values that matter for people doing end clients on Windows 7 are these, A, B, and C, and almost always C. 255.255.0.0, 255.255.255.0 is the one you'll almost always see because it's appropriate for small networks, like end devices. The default gateway has to point to the router. It is traditionally a number ending in 1, although sometimes people use 254. You could use any number, but typically use the beginning or the end of a range to avoid accidentally assigning that to an end device. If you don't have a default gateway, you can't get to the internet. If your TCP/IP configuration is wrong, usually just restarting your machine will do it. Right-clicking anywhere, like right here, right in the network thing, you can right-click and hit Troubleshoot Problems. And it will run the Network Diagnostic utility, which will try, like the 10 most common things. This will usually fix your problem. You can also go to Command Prompt and do IP config renew. IP config renew 6 is intended for IP version 6, and as far as I can tell, it does not work. I've never seen it do any good. All right, if your DNS is not right, you can, one thing that is a useful thing to know is to memorize a working DNS server. Because in case the DNS server wherever you are doesn't work, you'll wish you knew one. I used to use OpenDNS for this purpose. That's a free DNS server, 208.67.222.222. Then Google made one. It's even easier to remember, 8.8.8.8.8. There was a real old one like 4422, which is technically not really a public one intended for use, but some company put it up and just left it up, and people all like that memorized. You should have one of these things memorized, so that when you're someplace and DNS doesn't work, you can get to a working server. You can use this all the time and that all the time, and it'll be fine. There are some slight disadvantages. This one will filter out dangerous websites. That's the main purpose of it. If you use OpenDNS, it will refuse to go to sites that are known dangerous. It'll pop up a box saying OpenDNS is blocked. This one will tell Google everything you're doing. If you have some illusion that Google doesn't already know everything you're doing, this will perhaps seem like a risk to you, but unless you're doing something exotic, Google already has 100 other ways they know everything you're doing, and so I just use it casually all the time. But anyway, it does, of course, mean that Google knows everything you do. All right, here's the other one. There's Google 4222, that's it. I never used that one. It's actually not really intended for public use, but a lot of network engineers have been using it for 10 years or more. They don't seem to turn it off. I guess they don't care. The hosts file is the original thing before there was DNS, when the internet only had like 50 or a few hundred machines. They just had a file you would download from a server or mail people a floppy in the mail, and that file had a list of all the IP addresses and all the names of the machines on the internet. And it's still in your C drive, in this folder called ETC, which is a Unix name. It's not a Windows name because the internet is Unix. TCP/IP was based on Unix. Microsoft ignored it for a long time, thinking it was no importance. And they came in the game late, so they actually had to just take Unix standards and build them right in. So it's the etc/hosts file contains all comments by default, except for 2 entries that go to your own machine. The IPv4 loopback and the IPv6 loopback. But you can put other machines, other addresses in the hosts file if you want to, and there are things you can download from the internet called internet accelerators that will do this, and there's malware that will do it. So if you go, I believe I resolved it. Oh, here's the joy of the statistics that I got from Half Bing. It finished. So this tells me the percent of loss for each of these devices, in case you find that useful, which I do not. Anyway, so someplace back here, I found an address for Yahoo. Maybe I'll just have to do it again. Looks like it will. So if I do ns lookup, yahoo.com. Okay, there's a Yahoo address. Highlight it, mark, highlight, copy with enter. Okay, let's mess with that file. I have to run an elevated notepad. A non-administrator notepad will not work. And now I can mess with the host file. I do Control-O to open the file, and I have to go to C, Windows. System 32, I think. Drivers. I have no idea why it's in drivers. That makes no sense. And like I said, the ETC isn't even Windows name, but that's what it is. And there is the glorious hosts file. So now I can put, I've got some left here from before, at least I commented them out. So I can put in that address and call it ccsf.edu. I can put in that address and call it Fred. Okay. I can save that. And now if I go to a browser and I open ctsf.edu, it's Yahoo. And if I open Fred, it's Yahoo. You can put anything you want. That's spelled right though. HTTP Fred. Yep, Fred is also Yahoo, and on you go. So you can do anything you want here, and this is a Brazilian attack called Farming. It was the first malware to use this that I heard about 5-6 years ago. You get infected, and all it would do was it would add an entry here that resolved the Brazilian bank to a fake server. And then they just wait, and next week when you go to your bank, you're actually going to their server giving them your password. They call that farming because you're planting a seed and the money comes in later. But that's the thing to know about. The host file is still there, doesn't really serve much of a purpose anymore, but it is one place you can do the mapping. If the mapping of name to IP address is in the host file, your computer will not look anywhere else. It will not ask the router, not ask any server on the internet. It'll say, no, I don't need to ask, I already know where that thing is. So if you do get false information in this file, then people can't get to those websites, and you can't fix it without fixing that file.
The Spybot Search and Destroy, one of those used to use the host file as its way for, they put bad addresses in there and then just have them reroute to something.
That's right. You can block ads with it. I have students doing that. Yeah, and also I remember from I ran Spybot Search and Destroy would actually warn you if anything tried to change those files, pop up a box. It is a place, it is a vulnerable spot in your system. Right, if you do resolve any domain names, they'll be in the DNS cache. You can clean it with ipconfig/flush DNS in case it gets the false information in there. The Diagnostics utility will automatically do that in addition to all the other things it does. Wireless networks can be irritating. If you connect to wireless networks, you'll remember them and try to connect to them later, and then they might connect to the wrong one if there's more than one network around, so you might have to clear these out or adjust the order they're in. So in network and sharing, managed wireless networks lets you control all the wireless networks your machine is remembering. This is a minor convenience issue for you. On Macs, this is a much more serious issue because every time you boot up a Mac, it sends out packets looking for the last 5 networks, broadcasting where you've been. So Macs violate your location privacy every time you start them up. Also iPhones. All you have to do is run Wireshark and you can find out the last 5 places anybody with an iPhone has been every time you turn it on. Anyway, you can change the locations. You can merge or delete network locations if you want to, so in case you have networks that are with multiple access points with different names, but they're really on the same network. You can set the workgroup name, which is really not essential in Windows 7, but you can do it. We talked about these network connections before. If you go into, you have these protocols you can adjust here. Here's the client for Microsoft Networks that lets you access shared files and printers. Here's the file and printer sharing, lets you share your stuff. QoS is for quality of service, and it really doesn't make any difference on end devices. It's for routers and switches to separate high priority from low priority traffic. IP version 6 and IP version 4 connects you to other machines and the internet. IP version 4 is mostly used these days, but a lot of Microsoft services are actually using IP version 6 now. Then you have the 2 we talked about already, link layer topology discovery, mapper and responder. Those are used to locate machines and place them in that map. All right. Here's Windows 8 developer preview. I got it a few years ago. Windows 8 has Microsoft Network Adapter Multiplexer Protocol, which I think would make you think you can combine multiple connections to get higher speed, but I'm not quite sure what it does. Now that Windows 8 is out, I should go find out what it really does. LLDP protocol driver 2. Maybe they took these out. These are in the developer preview. I haven't looked at the finished version of Windows 8 to see if they're in there. Anyway, so your IP addresses are 4 8-bit numbers for IP version 4, which is the most common. So you can get numbers like this, 147, 144, 12. And every device has to have all these settings. An IP address, a subnet mask, a default gateway, and a DNS server. If you don't have all those numbers right, your machine can't network. That's why everybody prefers to use DHCP, where it just gets all those numbers from the router and you don't need to know or care what they look like. But we are the experts, so we will be called in to troubleshoot it, so you have to know how to do this stuff manually. The subnet mask is there to tell your network what part of the address is the network portion and what part is the host portion. If I go into adapter settings, and I guess I can do status. Okay, here's the numbers, the all-important numbers. So 147, 144, 5179 is my IP address. That's a 32-bit binary value. It's 4 8-bit values. The 255, 255, 2550 tells me that where you see a 255, this is a network part. Where you see a 0, this is a host part. In binary, it's 1s and 0s. This is 8 1s. So that means the first 3 bytes here determine what network I'm on. The last one determines which specific device is that network, the host part. Here's my gateway. One number, one device on your local area network has to be a gateway to get off, or you can't get on the internet. So in this room, it's 147, 144, 51, 1, which is, like I say, usually you put 1 at the end for the gateway. And then I have DNS servers. In this room, I've got a college server and I got OpenDNS. You got to have one of those, or you're not going to be able to use any alphabetic names on the internet. So if you don't have all 4 of those values right, you're basically unable to do any practical networking. Yeah. Oh, it's out there. Oh, sorry. All right. So DHCP is what almost everybody uses to configure these on end devices. If DHCP fails, then you get a PIPA, automatic private IP addressing, that fills in on 169.254, and you won't be able to get on the internet with a number like that. That's why you should be aware, as a help desk type person, that's the number you look for. Static IP addressing is used commonly for servers, rarely for end devices, because if you get it wrong, you foul up the whole network, foul up somebody else. It's more administrative effort to put them out there. We use it at this college, although I think I'm slowly convincing them to knock it off. You can actually choose not to use a PIPA. If you go into your IP version 4 properties, there's an alternate configuration tab where you can specify a different address. And this is, for example, if you were at a college like this that uses manual addressing, and then you go home or to a coffee house that uses automatic addressing, you can set it to try automatic addressing, and if it fails, put in this manual address instead of 169.254. It would actually be useful for people who work at this college, where you use, when you go to work, it'll take an extra couple of minutes booting up while it tries to get an automatic address, then fail over to your work address. If you go to a coffee house, it'll find the coffee house address. So it is kind of useful in that regard. And if you do fill this in, then you'll never get 169.254. You'll either get the DHCP address or whatever you put here. It'll never switch over to that PIPA address.
What about
Yeah.
reservations in DHCP? Do people use that much? Because in my first job, we used it loads, and
You can,
I thought it was very effective because it's managed by DHCP, and you can always see what machine it belongs to. But they like having a static address.
So some people do that. Then you have to type in the MAC address for everything.
But you just do it once. Yeah.
Just do it once. Right. Well, you have MAC address filter here. It's like MAC address filter. You can have a DHCP server that always gives you a reserved address. That's one way to go. Yeah, it's a possibility. We just have static addresses here. But that's true. It's good to mention. But you don't configure that on the client. That's configured on the router.
You don't have to set it on every machine. You just have to enter the MAC address on the server.
In IP version 6, that gets very easy because you can set the mode so that it creates the IP address from the MAC address. So it's always predictable. But yeah, that is an issue. You can reserve on the server. So everything has to have a public IP address, which you basically rent from a phone company, or you can't use the internet. That's got to be a public one that no one else is using, guaranteed to be just yours. What most people have is in the early days, they have dynamic addresses, where when I dial up, I use the number, and when I hang up, the next customer dials up, they give that number to the next customer. Technically, most home internet connections are still dynamic, but in practice, they almost never change anymore. Because everybody's pretty much on all the time. You pretty much stay with the same address for a long time. Some people try to use this as a defense when they downloaded pirated movies. Oh, somebody else had that IP address, but that doesn't really save you much these days. So a private address is ones with 10s, 192, 168, and this means you don't have any direct connection to the internet. You have to go through the translation device on the way out. A lot of people regard that as a security measure because from the outside you can't tell any structure with the internal network. It looks like just one machine, no matter how many machines are sharing the internet. But the main reason people do it is to save money. Have many machines share one network connection, only pay for one public address. So you have private addresses down here, like 192.168, 101, 102, and they have to have 2 ports on the router. They have a local port, which has to have an address on the local network, and then they have a public address, which has to really pay the ISP bill, up here 147, 144, and this router translates all the traffic. It's doing it by translating the address and the port of every request. All right. So these are the reserved private ranges that you should be handing out. There were some companies that actually used some informal ones like 50, because for a long time there were certain undesirable addresses on the internet, and people got used to using 50 as a reserved private range, and then they finally allocated 50 like about a year ago because it totally ran out of IP version 4. So it's a good idea to stick to the official ones. There aren't enough, by the way. Sprint is in big trouble. Sprint has so many cell phones, they've used up all these addresses 40 times over. So there are 40 phones with the exact same IP address, going through 2 layers of network address translation untangles. That's why they have to go to IP version 6. With much longer addresses, so you don't have stupid problems like that. There really are only 16 million and change of these. And that sounds like enough, but it's not really enough if you're Sprint. You've got a lot more than 16 million cell phones. So
When do you
IPv6,
think
what's
they'll
that?
start using IPv6 here?
What's that? When are we going to start using it?
Yeah.
Pretty soon, I think. We're talking about upgrading to it. We're going to go behind Cloudflare, so our website will have IPv6 very
I
soon.
mean, in the United States.
It's coming. Comcast now provides IPv6 for home users, but not business. It's very slow in America. You can't get a business IPv6 connection for love or money right now in America. But it's got to happen soon, because in 9 months, North America will run out of IP version 4 addresses completely. And then you can't add any more new devices without switching to IP version 6. So, like so many things in America, it is amazing how we are 9 months from falling off a cliff, and 99% of people are still doing absolutely nothing to prepare for it. Anyway, this happens a lot. Like look, Washington and everywhere, and city colleges, many people around here just, everything's fine right until your front tires go off the cliff, and then you say, hey, maybe we should do something. So, anyway, here's IP version 6, these really long addresses with colons in them. The colon means you've skipped a bunch of zeros, but they're a whole lot longer. They're 4 times longer, they're written in hexadecimal. There's an essentially infinite number of them. It takes the total number of addresses on the internet and raises it to the 4th power. It is a stupid number, too big to even think about, bigger than billions or trillions or anything. So you'll not run out of addresses anymore. And you can get your IPv6 certification. I think I'll be teaching this class again next semester. I highly recommend it. I've got at least one student got a significant promotion or another job because of this. People are discovering that they need IP version 6, and it is not easy. So here you practice setting up the usual thing. The web server that hands out web pages of IPv6, email and DNS, servers to hand things out over IP version 6, and then you get a certification. It's nice, fun test. It's a hands-on certification. You have to really configure these servers, and they test them, and they have to really work. So that's good. Anyway, you can take that class next semester if you want to get that cert. It's fun. So I got a few addressing questions to go through here. Let's try a few of these. There's a project an extra credit project where you do this. So here's a good network. You have a subnet up here. This is 192. Let me make this bigger. Okay. The subnet here is 192.168.1.0. It should have a /24 there. I didn't put that in the slide. But this is a most common network. The subnet mask is 255.255.0.0. So the first rule is the subnet mask has to be the same on every machine. Whoa, my crazy taskbar is in the way. Let's get rid of that. There, okay. Now, so this machine is 192.168.1.1. This machine has 2 network cards. The one I showed you is the local one. It also has a WAN port that goes off the internet. So all these other machines have to have 192.168.1.1 for the default gateway, or they're not going to get on the internet. The only other rule is every machine on this network has to have the same network portion of the address, 192.168.1, and the last one has to be different. You can't use the same number twice. So this is a good network. You put 1.1 here. This one's 1.1.01, 1.1.02, 1.1.03. This is typically what you would get in a normal network. Everybody has their own address, and everybody can reach the internet. That's the way a network should be. Now, if you try to use the same address on 2 machines, it won't work. One of them will not get service. In fact, if you're using Vista, and I think Windows 7 about half the time, they will both connect and lose half the packets of each one. Instead of putting up an error message, if you use an XP, one of them will just refuse to connect and get 000. But anyway, this is a bad practice to use the same number on 2 machines. If you have an IP address outside the subnet, This is 192.168.2, but the network is 192.168.1, you won't be able to send or receive any packets to anybody. If you have the wrong subnet mask, like 255.255.0.0, mathematically and logically, I would think local traffic would be okay. You could still reach the printer, but you can't get to the internet. But at least for Windows XP, last time I tested it, this means you can't send or receive any packets. It won't work. You've got to have the right subnet mask or you're out of the game. And the wrong default gateway, if you put in the wrong number for the default gateway, this one will take its internet packets and send them to this machine, which will just throw them away, saying, I'm not a router, I don't know what you're talking about. And so this guy will be able to still receive the printer and shared folders, but he will not be able to get on the internet. So those are the mistakes you can make with manual addressing. So in that spirit, what's wrong with this network? It's A, B, C, or D. Which machine is wrong? Four people are faster than me. Oh, there it is. Ah, yes. Okay. 6 people are faster than me. Feel free to come closer if you want. That is a little hard to see. All right, I guess I'll quit at 1 minute. All right, coming up on 1 minute here. All right, the problem is 192.169 instead of 192.168. This, you're not getting anywhere with an address like that. What is wrong? I had, some extra credit homework where you do 10 like this, and I had a student, I took a point off, he had one wrong. He sent an email, said, no, I was right. I said, sorry, that one's wrong. I said, listen, I got Cisco certification, you're just a stupid teacher, you're just an idiot. I know more than you, I do this stuff on the job all the time, and I said, well, that could all be true, but it's still wrong. And the interesting thing was how crazy he got. 7 times back and forth until he was swearing at me and calling me names and everything. People get this guy, but it's really easy to overlook these little things. And there's a problem in our business. The network engineers tend to be bad people. They tend to be rude to everybody, think they're smarter than everybody. Watch out for that. Anyway, so, all right, how about this one?
Can we turn this off? The glare is...
Yeah, sure.
Yeah,
Feel free. See if it makes that to be better. Yeah. Not better. Oh, okay. 4 people are faster. All right. Guess I can put it 50 seconds on this one. All right, and problem is B, as everybody found, he's got a subnet mask. You're not getting anywhere with subnet mask like that. Okay. All right, how about this one? Oh, I'm gonna have a little trouble grading this one, but it's all right.
Yeah.
It's still useful. Yeah, pick one. I won't grade it.
Well, that's, yeah.
Can you just bypass that one?
No.
I guess I'll quit it. But still, I'll wait for 45 seconds.
Looks like wait a second to be this. Yeah.
All right, so the answer is C or D. Right.
Or does it matter?
I can't grade it. You got duplicate addresses. You got to change one of them.
Yeah.
Either change either of them, it'll be fine. Yeah.
When that happens, do both C and D not, or does C, because it comes first, get
The
it,
one
but
that
then
boots
D
up
doesn't?
first will get on. The second one won't get on. So it can drive you nuts. Like, just get a help desk call, fix this machine, there's nothing wrong with it, and tomorrow it's this one, and tomorrow it's this one again, and both of them seem fine when you go there. That's why manual addressing is such a drag. DHCP will prevent this nonsense. All right, how about this one? See if we got one answer this time. Ooh, I see it. Ah, nobody was faster than me. I'm lucky. All right, guess I can split it 40 on this one. All right, so B has got a bad default gateway. B has got 192.168.2.1. B will not be able to get his email because there is no such machine to send his packets to. All right, oh, this one. Put it 40 seconds. All right, A is bad. You got the wrong address up there, so nobody can get on the internet because the gateway address is wrong. So
Wow.
that's bad. That'll do it. They're all going to send packets to 1.1, and there is no 1.1. So everyone's off the internet, except for this A by himself, A can serve. All right, so I got some more iClickers about the usual stuff. So Joe can't get his email. There's his IP config. So what do you recommend? All right, I guess I'll quit 40 seconds here. All right, that's the magic 169.254. That means DHCP failed, so you just need to restart the computer. It's not the lack of gateway. There's no gateway you can put there that will work. He didn't get his settings. You need to restart the computer or do ipconfig/renew. That's the problem. This magic number tells you that. That's all you need to see. When you see that number, you know just what happened. You need to restart your machine. Now, it is possible that the DHCP server is really down, and everybody's getting that number, in which case restarting won't fix it, but that's rare. Usually it just means your machine only waits for a limited amount of time, like 45 seconds or a minute. And it's fairly common that the server is busy and it doesn't answer in that time, and you just need to try again. All right. So Joe can't get his email. And you try a ping, a couple of pings, and that's what happens. So what's the problem? I better wait until 50. All right. So he's on the internet. He can get to Google, but he just can't get it by name. So that means his DNS is wrong. It's D. Everything's fine with the network except the DNS, because you're able to get all the way over to a remote server. You just don't have DNS working. So the DNS settings are wrong. All right. So Joe took his laptop from work to a coffee house, And now he can't get his email. So what should he do? Wait till 50. Okay. And the right answer is D. Most people got it. You can see right here, DHCP is turned off. He's using manual addressing at work. He probably works at City College. And therefore, these addresses are probably wrong. 5-1 and 549, that's from work. Just turn on DHCP when you're at a coffee house, and you'll get whatever the addresses are they're using there. All right. So, Joe can't get his email. What would you do now? All right, so again, D, he's got to fix that subnet mask. You're not getting anywhere with a subnet mask like that. All right, and so that's it. I'll go up to the, let me see who got the most eye clickers right. All right, 12s and 11s have it.